Welcome to our new video, and today we're going to move on with this topic of rational numbers, this time with addition of rational numbers. So first of all, we are going to convert every decimal or mixed number into a fraction. So every single time that you see a decimal or a mixed number, you know that you have to convert it into a fraction. For instance, here 0.5 is equal to 5/10. Why a 10? Because there is one decimal here, so there should be 1 0 here. If we simplify 5/10, that gives you a half. Now the mixed number 2 and 5/9, how can I convert it to a fraction? You just have to multiply 2 times 9 plus 5, which is 18 plus 5, and the answer is 23/9. So basically, how can we add rational numbers? Well, if both have the same denominator, it's really easy, but what happens if they have different denominators? So, well, let's take a look first at the case where we have the same denominator, and here we have it. I have 2/6 plus 1/6, so the answer is really easy. I have 3 parts of 6, so the answer is 3/6. Basically, we just have to add the numerators 2 and 1 and keep the same denominator. But what will happen if we have, for instance, a half plus a third? Here I have the graph, so we can see it, how it's going to be performed, this addition. I'm going to do it in a graphical way. So I'm going to move this third right to this part, and there we have it, a half plus a third. And what if I cut this rectangle in six parts? 1, 2, 3, 4, 5, and 6. There I have it, in parts of 6. So as you can see, there are 5 colored parts, 5 of 6 parts. So how is it possible that a half plus a third equals 5/6? How can that happen? Well, let's do it another way. What if instead of cutting the third from here, I will cut the half from here? Let's see what we'll get. Here I have the half, and I'll place it right here. Once again, if I cut it in pieces of 6, 1, 2, 3, 4, 5, and 6, I'll get the same answer. 5 colored parts out of 6. 5/6. So how that can happen? How can a half plus a third equals 5/6? Well, for that we need to find the least common multiple of both denominators, of 3 and 2. And how can we find it? Well, we can find all the multiples of 2, which are 2, 4, 6, 8, 10, 12, and so on. They're infinite. And the multiples of 3, we have 3, 6, 9, 12, and so on. Among these denominators, there are some that are common. For instance, 6 and 12. But among these common multiples, there is only one that is the least of all, and that one is 6. What are we going to do with that 6? That is going to be our new denominator. But there is another way to get the least common multiple of two numbers, and that is factorizing. For that, we need to divide. First, I'm going to divide 2 by 2, and the answer is 1. With 3, well, it's impossible to divide it by 2. if we want to get integer numbers, so we will divide it by 3. 3 divided by 3 equals 1. What I'm going to do with those two numbers that I found, the 2 and the 3? Well, I'm going to place it here. These two numbers comes from here, 2 and 3. Alright? And on the other side of the equal sign, I'm going to place the numbers I found on the right side of the vertical line. For 2, I just found a 2. For 3, I found a 3. But I won't place it here because there can be different numbers above each other. So I'm going to place the 3 right over here. From every column, I will load one number, just one of them. And from this column, I will load a 2, and from this column, a 3. And 2 times 3 equals 6. You choose the method you like the most, but I would recommend this one. Alright, remember, our new denominator is going to be 6, and we need to find equivalent fractions for every single one of them. So for that, I need to ask to the 2 what number multiplied by what number gives it a 6, and 2 multiplied by 3 gives you 6. So I'm going to do the same with the numerator in order to get an equivalent fraction. So 1 times 3 equals 3. And here I'm going to multiply by 2 because 3 times 2 is 6. And I will do the same right here. 1 times 2 equals 2. And now that I have the same denominator, I can add 3 and 2. The numerators. 3 plus 2, 6th, which is equal to 5/6, the number that I got previously in this part. So that's how we can add fractions with different denominators. We must find equivalent fractions with the same denominator, and for that we need to find the least common multiple of the denominators. Well, if you remember, rational numbers could be negative. So what will happen if we have to add a negative number just like here? As you can see, well, there is an addition of a positive and a negative number. And here we have different signs separated by a parenthesis. What will happen in those opportunities? It's very easy. We have to multiply both signs, and positive multiplied by negative, it's negative. So the addition became in a subtraction. 6/7 minus a 5th. Well, the least common denominator of 7 and 5 is 35. You check it out. 35 here and 35 there. In order to get a 35, I must multiply 7 by 5, and I should do the same with the 6. 6 times 5 is 30. Minus, remember that our addition became in a subtraction. And 5 times 7 gives you 35, so I shall do the same with the 1. 1 times 7 is 7, and 30 minus 7 is 23. 23 35th. That it is the answer. Now, what could happen in a case like this? Minus 4/5 plus 9/5. Here I have an addition of a negative and a positive. Unfortunately, we have the same denominator, so I'm going to place it 5, and I'm going to write down here minus 4 plus 9, which is equal to 5, a positive 5, by the way. And you can simplify this fraction. If you divide both numerator and denominator by 5, that will give you 1. And remember, every fraction with 1 as a denominator is actually an integer. The answer is 1. So that's it. So what will happen if we have, or what if there are negative fractions? Well, it's very simple. if the negative is separated by other signs, by a parenthesis, you have to multiply the signs, and just the signs, not the numbers. Well, here they weren't separated, but they were arranged in another way. We had -4 plus 9, they were in parentheses. Well, we have to operate. That's it. So, well, I hope you could understand this. Next time we will go on with subtracting rational numbers. Goodbye.